Hey, this is the second video. We're looking at transformations in more detail. In the last video, we had a look at dilations, and we started getting this idea that dilations or all transformations affect either the input or the output in order to create a brand new function. So we had dilations last time, which is a stretch or a compression for an input dilation. Okay, so that's when we're replacing x with a new value, or a new expression, I should say. Then we would say it's a dilation towards or away from the y-axis with a factor of 1 on a. Okay, so looking over here, if I have 2 here, then that would be a dilation of factor a half. If I put 0.5 here, you'll see that the graph is now stretched away. 0.11 is now doubled to 0.21. So the x-coordinate has doubled. Every x-coordinate has doubled, so it's stretched away from the y-axis as a result of doubling all the x-coordinates. And 1 over a half is equal to 2. So that we would say that for this particular function, we would say it's a dilation away from the y-axis with a factor of 2. Okay, it all feels counterintuitive. Whenever we're talking about inputs, it always feels counterintuitive. Okay, so that's just a little bit I wanted to finish off with dilations, which I didn't include in the last video. So let's have a look at reflections. Reflections are basically mirror images. Okay. And they are controlled by whether we put a negative in front of the input or we put a negative in front of the output. That's basically it. So again, we consider them separately, and they reflect in different ways, I suppose. So let's have a look at it. It's pretty straightforward. So if I put a negative in front of the root x, I might do it on the parent function, not on the parent function, we can see that it is actually exactly the same graph, but it is now underneath instead of on top. What it means is that every single point along here now has a negative y-coordinate instead of a positive one. And if this graph did go down to the negatives, which the red graph doesn't, then they would go positive because a negative is a positive. But just to take a few points so you can see what I mean, 0 is now 0. 1 is now 1, negative 1. There it is there. There it is there. If I can just hit that spot. 2 and 1.4 roughly. Can't quite hit it. Yeah, there we go. Is now 2, negative 1.4, etc. Okay, so every single point, now the output has now just been transformed so that it is negative instead of positive. It's changed sign effectively. Okay, so what we say is that the function has been reflected. So this is for the output. The function has been reflected about the x-axis. Okay, it's been mirrored across the x-axis. Do note that it's not just mirroring at that point there. It doesn't have to join up like it has here. If this function started up here, then it would be mirrored down here. I'll show you what I mean, just so that we've got a bit of an idea here. I'm going a bit further than I wanted to with this, but I just wanted to give you the sense of it. So you can see that the starting point, it's not mirrored there. 0, 1 is now 0, negative 1. 1, 2 is now 1, negative 2. So the output has been reflected, has been made the opposite sign. Okay, so just keep that in mind. Get me back to the start. So the two parent functions here. So that's the output. Let's have a look at what the input will do. Again, you might want to pause the video and think about it for yourself. Okay, you either have or you haven't. When I put a negative to the input, we now have the same shaped graph, but it has now gone backwards instead. And that kind of makes sense, I think. It means that the input is now negative where it once was positive. So it changes the sign of the input. So what was 1, 1 here is now negative 1, 1. So the Y input didn't do anything. Sorry, say that again. So the output didn't change. It's still 1, but the input did change. To get to 1, I now have to have X as negative 1. Yep. Whereas in the original graph, to get to 1, X had to be positive 1. So that's the effect. And we say that's a reflection. So for the outputs, for the inputs, we say if the input has been made negative, it is reflected about the y-axis. Okay, because it's affecting the x values, but the result is that it's reflected about the y-axis. It's the same thing if I put a +1 here. I'll make it -1 just so it stays on that side, and I put a -1 here. Sorry, let's do that. Okay, if I put a oh no, that's going to make it too tricky. I'll just leave it at that. If I put a -1 there, you'll see that it is the same reflection. What was 1 unit across this way is now -1 unit across this way, and so on. So hopefully that kind of makes sense to you. Okay, so that's reflections. I think I might just stick in this video as well translations, and then we can have a look at how that affects a transformation in total. So let's go back to the parent graph of root x like so. So translations are shifts. Okay, they move the whole function, holus bolus, up or down. And again, we have an effect on the input, or we have an effect on the output, like so. Okay, so we will have either the input being changed. It doesn't matter what the variable you call is, but normally we use h and k for this. So the input is plus or minus h. The output is plus or minus k. And let's have a look at what it does. Let's have a look at the output first, because that's probably the easiest to sort of see what's happening. So I'll just zoom in a little bit like so. So if I add a value like 2 to the end of that, now this is not a stretch this time, it is a translation, which means that every single point has been moved up. Sorry, I'll just make a second one. So if I add 2, so the original function, remember that transformations of the output means that it affects the whole of the function. So square root of x was the function. Now we're taking that output and adding 2 to it. So where it was 0, the square root of 0 is 0. It is now 2. Where it was 1, 1, it is now 1, 3. That's not a scale, that's an addition of 2 units upways. Where it was 4, 2, it is now 4, 6. Like so. 4, 4, sorry. 2 plus 2 is 4. So everything has been directly translated up by 2. And of course, I could subtract 2 instead. And now every single point has gone down by 2 units. So 0 has gone to -2, looking at the y, the outputs. 1 has gone to -1, and so on. They've all gone down by 2 units. So that's how the output has been transformed. Inside, again, it's a little bit counterintuitive. So if I add a value, what I'm doing effectively is I'm saying instead of x, I now want it to be x plus or minus a value. Okay, so let's make it x plus 2 so we can see what happens. Again, you might want to pause the video and say, what do you think is going to happen? It's going to be a translation of every point, but what does that mean? Okay, either you paused or you haven't. Here it is there. There it is there. Here it is here. What we have is that when we add 2 to the input, the whole graph gets shifted back by 2. Because for an output of 0, I need x to be -2 because -2 plus 2 is 0 and the square root of 0 is 0. So it in fact translates each point backwards by 2 units. We know that 1 squared is equal to 1. Sorry, the square root of 1 is 1. So in the new function, in order to get 1, I'd have to start off at -1 because -1 plus 2 is +1. Square root of 1 is 1. So in other words, -1 gives me an output value of 1 now. So everything has been translated back by 2 units. 4 on the old graph gave me an output value of 2. Now if I go back 2 units, I've got 2 giving me an output of 2. Okay, so everything has been translated back by 2. And similarly, if I click on -2, it's exactly the same story but in reverse. In order to get to 0 now, the square root of 0, I have to start off with x equal to 2. Hence, we've got 2, 0. If I let x equal to 1, I'd have the square root of 1 minus 2, which is -1, and the square root of -1 is not a real number, which is why there's nothing here, even though there is a value here. So everything has been shifted forward by 2. In order to get 1, x would have to be 3. 3 minus 2 is 1. The square root of 1 is 1. So there's 3, and there's 1. In order to get 4, square root of 4 is 2 on the original graph, I'd now have to go to 6 because 6 minus 2 is 4. And so we have a translation of those points. Okay, so as you can see, the best way to look at transformations is to consider whether they affect the input or the output, whether it's a dilation, reflection, or translation. And then you have to consider whether they're going to have sort of like a positive effect or a negative effect in a way. And thirdly, whenever it comes to the input values, often the what happens to the graph is often counterintuitive to what you may think. Okay, so subtracting a value from x in the input value actually makes the graph shift right, or the scale factor for an input value is 1 over whatever the number is in front of x because of the way it compresses or stretches. So it's something to keep in mind as well, that just make sure, particularly when you're dealing with input values, that you are getting it right in terms of the effect. Okay, this video has gone on long enough, so this is part 2, which has dealt with reflections and translations. In the next video, we'll have a look at some practical examples so we can get a good sense of what's going on.